In this problem, the students are writing the ratio in simplest form. They need to know that simplest form means that they are dividing in order to get to a common factor of 1. So they can go ahead and put this in a ratio table of brown hamsters to gray hamsters. And since brown goes with 16, 16 goes on top, 14 goes on bottom. And they can use their ratio table to simplify or put it in simplest form. So they would divide by 2, which makes 8. They divide by 2 on the bottom. Got to do the same thing top and bottom. 14 divided by 2 is 7. So in this case, it would be 8 to 7 would be our simplest form ratio. For problem 2, you're again writing in simplest form, which means that you will be dividing in order to get it down to where you can't divide anymore. So they have a common factor of 1. So we'll go ahead and set up our ratio table. And this time we're comparing 12 candy bars out of 30 pieces of candy. So I'll put CB for candy bars, and I'll put C for candy. 12 is the candy bars, and 30 is the pieces of candy. So we're going to simplify, which means we're going to divide. So I'm going to go ahead and divide by 2 because I see that both are even. 12 divided by 2 is 6. 30 divided by 2 is 15. You may stop here thinking that there's nothing that they have in common, but if you think about the factors of 6, which are 1, 2, 3, and 6, and the factors of 15 are 1, 3, 5, and 15, you would divide by 3 since they have a common factor of 3. 6 divided by 3 is 2. 15 divided by 3 is 5. So candy bars to candy is a 2 to 3 ratio, or excuse me, 2 to 5 ratio. In problem 3, Jill can type 180 words in 3 minutes. What is her average pace? Average pace is the same as finding constant speed. So what we're looking at here, again, this is constant speed, is we are trying to determine how many words per minute she can type. So we'll go ahead and put this ratio in a ratio table. And we're going with words and we're going with minutes. And it's 180 words in 3 minutes. So if we're finding our constant speed, we want to find out how many words Jill can type in 1 minute. So I'm going to put 1 over here. Well, the only thing that I can do is divide by 3 in order to get to 1, so I have to divide by 3 on top. The students know a quick little trick, and it says how many times does 3 go into 18? It goes in there 6 times, and then we put in a 0 because it's actually 180, not 18. So Jill can type 60 words per minute, and that's her average pace. Jose can run 6 miles in 2 hours. At this rate, how many miles can he run in 5 hours? So right now we're comparing miles and hours. So we're going to again set up a ratio table to solve. And our word comparison is miles and hours. And Jose can run 6 miles in 2 hours. And we want to know in 5 hours. So I have hours on the bottom, so 5 is going to go here. In this problem, you cannot easily go from 2 to 5, so you have to let your ratio table do the work. Additionally, if I go ahead and I double this, and I double 2 to 4, and I double 6 to get to 12, if I double again, I'm way too much. So what I'm going to do is I'm going to go back to 2, and I'm going to go ahead and divide by 2. I'm going to find my unit rate. So 2 divided by 2 is 1. 6 divided by 2 is 3. And now at this point, I can see that if I add 4 plus 1 together, that gives me 5. So I would go to the top and add 12 plus 3 together, which gives me 15. So Jose can run 15 miles in 5 hours. Question 5 states, on a map, the scale is 2 inches equals 8 miles. If the distance between 2 cities is 5 inches, how many miles apart are the cities? So we have a scale problem here. So we have been taught that if we set up a scale, we always compare it model to actual. And in this case, the 2 inches is, the first number is always the model, and the second number is always the actual. So I'm actually comparing inches to miles. And it would be a comparison of 2 to 8. In addition, I'm going to take a look at the bottom here, and it says if the distance between two cities is 5 inches. So as I when we talk about this, we talk about the fact of what does 5 inches really look like, and is it possible for two cities to be 5 inches apart? Not in real life, so that has to be a model. So we're going to go ahead and put the 5 on the top because it goes with the model plus its measurements in inches, which is also the model measurement. Also, our problem asks how many miles apart are the cities, so we're looking for miles. So lots of cues there as to where to put your numbers. I'm going to go ahead and use my ratio table. I'm going to double it. I get to 4. I'm going to double it. I'm going to get to 16. If I double again, I get to 8, which is too much bigger than 5. So I'm going to go ahead and go back to, I'll go here and I'll divide by 4 to get to 1. So 4 divided by 4 is 1. 16 divided by 4 is 4. So again, I'm finding that unit right here. And then I can see that I can add together 4 plus 1 to get to 5. So 16 plus 4 makes 20. So in this scenario, the two cities are 20 miles apart. In this problem, it says if 30% of the class is girls, what percent of the class are boys? So if we know that 30% are girls, even though this has a percent and we may think it's a percent problem, we don't have anything that it's set equal to or that we're trying to find. All we're trying to find is what percent of the class are boys. So we know that 30 plus some number has to equal 100% because 100% is our total. So the number that would end up being here is 70. So 70% are boys. A pair of jeans sells for $30 and the sales tax is 8%. What do you pay for the jeans? I'm going to begin this problem by setting up a double number line, and I see that it is a percent problem because I have a percent here and I have a number. So again, we're looking at trying to determine the percent of the whole amount equals the part. So I have to plug in my numbers. I have the percent, it's 8% of. I have to determine if $30 is the whole amount. If a pair of jeans sells for this amount, then $30 is the whole. And we're trying to determine the part. I'm going to go ahead and use a double number line to solve. So we have 0, and we have 0, and we have 100, which indicates 100%. Percent's going to be on top, and dollars is going to be on the bottom, excuse me. The whole amount is $30, so that goes underneath the 100. I have to find 8%. So we really are going to need to know that you have to find 1%. And finding 1% means I'm dividing by 100, which means I'm going to take my decimal, which is at the end of 30, and I'm going to move it 2 places to the left. Okay? If I'm finding 10%, remember I move my decimal 1 place to the left. So let's go there first. We're going to find 10%. So 100 divided by 10 is 10%. 30 divided by 10 makes 3. So I know that my percentage of tax is going to be close to $3 because we have 10% here. So I am going to go ahead and find that 1%, and I can do it from here. I divide by 10. 3 divided by 10 is 0.3. We don't want to leave it as 0.3 because that doesn't make sense to us in money, so we want to put the 0 on the end to make it 30 cents. Now from 1, I can multiply by 8 to get to 8%. I can take 30 cents and also multiply by 8 to get $2.40. And notice that it is close to 3 because we are close to 10%. So my 8% sales tax is $2.40. I have to find out how much I'm paying for the jeans. So if they were $30 and I'm going to add to it $2.40, the total out the door would be $32.40. I'm going to go ahead and set up a ratio table to solve this one as well. And I have the information set up here. We still have our percent, 8% of our total $30 is the part. So we're going to set up a ratio table to go ahead and solve. And I can set it up one of 2 ways. I can compare 30 to 100 and try and find the 8 by the percent, or I can do 8 out of 100 and I can put the 30 on the bottom. So I'm going to go ahead and set it up with 30 on the top to 100 because that's our percent. And then I'm going to go ahead and put 8 on the bottom. So this is our percent here, and this is our whole amount here. So we're trying to find the part here, or I should say this is the dollars here. So I'm going to go ahead and divide by 10 because that's easy enough, just like we did in the double number line. So 30 divided by 10 is 3, and 100 divided by 10 is 10. I'm trying to make 8, so I'm going to go ahead and divide by 2 to get to 5. I'm going to divide by 2 to get $1.50. Okay, and again, I'm putting that 0 on the end so it makes sense to me for numbers. I'm going to go ahead and divide by 5 to get to 1. And I'm going to divide by 5. And in this case, if I want to divide $1.50 by 5, I can say, well, how many times does 5 go into 15? Well, that goes 3 times. So that's, again, there's my 30 cents. So here I would multiply by 8. I'd multiply by 8 to get my $2.40 is my tax. And I would add it again onto my $30 to get a total of $32.40. I'm going to show you one more way of doing it with the tape diagram. Again, we have 8% of our $30 is equal to our sales tax. So this is our percent. This is the whole amount, and we're trying to find the part. So I'm going to set up my tape diagram, and I'm going to separate it into 10 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We know that this whole thing is worth $30. So when I divide it into 10 equal pieces, each piece is worth 3. So what I'd have to do here is I'd have to break up this 10% into 10 equal parts. So I'm going to just do that off to the side here. Okay, and we're going to divide it into 10 equal parts. Okay, here's 10 equal parts. So I'm taking this 3 and I'm dividing it by 10. So each piece now is going to be worth 0.3. So this is going to be 0.3 all the way down, 0.3. And since I'm looking for 8%, I would count up 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. So here's my 8% right here, and I would just count up how much that was. That would be, again, $2.40. So I'd add that on to my $30 plus $2.40 is equivalent to $32.40. You go out to dinner and your bill comes to $50. You want to leave a 15% tip. What is your total cost of your bill? In this problem, I can see that I'm going to be solving a percent problem because I have a percent. So I'm going to go ahead and write our equation. Percent of the whole equals the part. And I'm going to go ahead and plug in. If my bill comes to $50, that means that's the whole thing. I have my percent. It's 15%. Of 50. So when I find my tip, that's going to be the part. So I'm going to go ahead and set up a ratio table to solve this time. And I'm going to go and compare 15% to 100. So I'm going to do a part to whole comparison here. And since 50 is the whole, that means 50's got to go on the bottom. And you can easily see that if I do 100 divided by 2, I'm going to get to 50. So I have to divide 15 by 2. Well, in this case, remember, we're talking about, we can look at this as like money. So I'd say, what is half of $15? That seems to stir some interest. Or we can go ahead and divide it out. But most kids would know half of $15 is $7.50. So in this case, if we have a $7.50 tip and they want the total cost of our bill, the tip gets added on. So I have a $50 bill plus my $7.50 I'm going to leave for the waitress. Comes out to $57.50. I'm going to show the same problem using a double number line. Again, we determined that the 15% of our whole bill is going to equal our tip. Okay, so with a double number line, I'm going to go ahead and set that up. We always put our zeros in here and we put our 100. This is my percent, and this is going to be my dollar amount for my tip. I know that this is the whole and this is the part. Whatever is attached to the of is the whole, whatever is attached to the equal sign is the part.